our next topic is Gauss's law in dielectric, means that what will be the equation of Gauss's law when we use a dielectric material between two charged plates or spheres or surfaces. Here, as we have a parallel plate capacitor, means two charged surfaces, so first we introduce here a Gaussian surface. So this is a Gaussian surface. Here we have an electric field which is directed from positive plate to negative plate, say E naught, passes through a small portion dA of the Gaussian surface. Then the flux can be written as phi equals to E dot dA, and this is closed integral. We know that here electric field and area both have the same direction, so E dA as a theta equals to 0. So equation 1. Gauss's law can be given as phi equals to 1 over epsilon naught into total charge at the plates, which is this one. Equation 2. From equation 1 and equation 2 we have E dA closed integral equals to 1 over epsilon naught q, or epsilon naught closed integral E dA equals to q, say equation 3, or epsilon naught by applying integral on area we have E A equals to q, and the value of electric field, which is E naught, equals to q over epsilon naught into A, equation 4. Here we have another figure of the parallel plate capacitor, but here we have a dielectric material, and when a dielectric material is placed inside a parallel plate capacitor, its molecules or atoms polarized, means that negative and positive charges are introduced. Let these are the negative and these are the positive charges. Again, here we will introduce a Gaussian surface, and suppose this is the Gaussian surface. Here these charges on the plates are Q, and charges introduced due to dielectric material are Q prime, then Q prime. In this situation these steps are the same, and from this equation we can write it as closed integral E dA equals to 1 over epsilon naught, and here the total charge is as Q is greater, it will be both are in opposite direction and Q prime. This is the equation, and from this equation we can, this is equation 5, and from this equation we can write it as epsilon naught closed integral E dA equals to Q minus Q prime, and by applying here integration we have epsilon naught EA equals to Q minus Q prime, or electric field can be given as Q minus Q prime over epsilon naught into A, say equation 6. We also know that electric field in vacuum and electric field when a dielectric material is placed inside the two surfaces can be related as E equals to E naught over K, and by putting value we have E equals to E naught is this one, Q over epsilon naught A into K, say equation 7. By equating equation 7 and equation 6 we have Q over epsilon naught A K equals to Q minus Q prime E epsilon naught into A, and cancelling we have Q minus Q prime equals to Q over K, say equation 8. So putting equation 8 in equation 5 we have closed integral E dA equals to 1 over epsilon naught into Q over K, and by multiplying these terms here we have epsilon naught K E dA equals to Q. So this is the Gauss's law. Here epsilon naught Ke can be written as equals to D, where D is the known as electrical displacement. By putting value we have D dA equals to Q. This is the more general form of Gauss's law in dielectric material.